So in this video we'll be focusing on proportion and focusing on links between ratios and fractions. Now there will be an attachment of a worksheet where you can practice any skills that you've learnt from watching this video. Now we can use ratios and fractions to represent proportion. Now we can also use, as an extension, we can also use decimals to represent proportion, and we can also use percentages to represent proportions, but more of the most popular ones are going to be ratios and fractions. Now although they can both be used for proportion and they can also be simplified in the same way, they do compare and use different components or parts of the grander total. So for example, if we had a bag that contained 4 red and 3 blue counters, so therefore we've got a total of 7 counters, then writing this proportion as a ratio, so we'll just get a different colour pen, we can see that we're comparing one part to another part. So we've got 2 parts in this particular bag. One part is red and one part is blue. Now when I say parts, I don't mean like an even spread, shall I say. What we're talking about is just general, how many sections have we got or how many parts have we got. So when we're dealing with ratios, we're always comparing one part to another. So here what we're doing is we're comparing one part to another, and that's basically what ratios are. They are comparing one part of something to another part of a grander total. Now when we're dealing with fractions, however, what we're dealing with is what we're comparing is we're comparing one part to the total amount. So when we're writing things as a ratio, we've got one part to compare it to another, and when we write things as a fraction, we've got one part as the numerator and we've got the total amount as the denominator. So again here the fraction of blue counters is 3/7 because we've got 3 blue counters and we've got a total of 7. So both can be used as a general total amount, however in terms of proportion. However, they're both using different sort of components of it. So when we're dealing with a ratio, it's going to be very difficult for you to know what the general total is. Likewise with a fraction, really. So we won't actually know what the total is, but basically what we're dealing with is looking at how many parts we've got. So here for every 4 red counters, we've got 3 blue counters, and that's in its simplest form. So giving us a total of that simplest form of 7 parts or 7 counters in this particular case. So when we're writing things as a ratio, we're comparing one part to another, and when we're writing things as a fraction, we're comparing one part to the total amount. But when writing things as a proportion, there is no sort of guarantee that the total amount is always going to be the denominator. The total amount is, there's no guarantee it's going to be, the total is going to be the sort of addition or the adding of all the parts of the ratio, which is may have come across in how we work out amounts of a ratio. So let's have a look at an example. So here we've got a very similar sort of situation. So here we've got a bag contains 4 red, 3 yellow and 6 blue balls. Write down in its simplest form the fraction of balls that are yellow, blue and red. So let's have a look at answering this particular question. Now if you want to have a go at this question yourself, feel free to pause the video and have a go, but like I said, what I'm going to do now is I'm going to run through and discuss how we get the answers to each of these parts of the question. So in terms of A, what we're doing is writing the fraction. So for this what I need to do is work out what the total amount of balls in the bag are. So here we've got 4 plus 3 plus 6, which gives us a total of 13. So when we're working with yellow balls, so here I've got 3, so it's going to be 3 out of 13. For blue, again I've got 6 out of 13, and for red I've got 4 out of 13. Now whenever you're using fractions, what you want to do is always make sure, can you simplify them? In these cases we can't, because 13 is a prime number, and so it's going to be very difficult for us to do that. So then moving on to section B. Now here what we're going to do is we're going to compare it to a ratio, so let's use a different colour for this. So here I'm going to write down the ratio. So here I'm going to write the first ratio is yellow to blue. Now when I'm writing this down, I need to make sure that the order of how the questions or the parts are written is the same order as I'm writing my numbers. So what I mean by this is yellow to red, so I'm going to write the yellow amount of balls first, which is 3, and then I have my sort of ratio symbol, and then I've got my red, which is 4, and then I check, can I simplify those two numbers? No, so that there is my final answer. For 2, and again what you just want to kind of do is just put a Y and an R. Now for part 2, the sort of parts have been reversed, so here we're doing red to yellow, so I've got red, which in this case is 4, and yellow, which is 3, and again I can't simplify that, so that there is my final answer. For part 3, I'm looking at blue to red, so again blue is 6 and red is 4. Now I can simplify that ratio because again 2 goes into both 6 and 4, so that then becomes 3 and 2, and there is my final answer for that one. And then finally for part 4, red to yellow to blue, so here we've got red, which is 4, yellow, which is 3, and blue, which is 6, and again I can't simplify those, so that there is my final answer. So let's have a look at another question. So here it says that at the end of the season a football team has won 3/5 and lost 2/7 of their games, and then part A asks what ratio of wins to losses, what is the ratio of wins to losses in its simplest form. So let's have a look. Now the problem is with this is the most common mistake that people would make is they would say for part A we're looking at the numerator, which is 3, so that's how many parts we've got, to 2. Now that there is not the correct answer. Now the reason why it's not the correct answer is because what we need to do is we need to write these fractions using a common denominator. So what I need to do is think to myself, I've got 3/5 and I've got 2/7. So what I want to try and do is find a common denominator. So I think to myself, okay, well what is a common denominator between 5 and 7? Well that would be 35. And then I'm trying to think, right, okay, well how can I rewrite 3/5 into a fraction where the denominator is 35? Well I need to multiply that by 7, so that's going to give me 21. And what do I need to multiply 7 to make 35? Well I need to times that by 5, so that's then going to be 10. So from this what I can now do is compare these two. So now that the denominators are both the same for these two fractions, I've got the total parts, which is 21 to 10. So here we've got the ratio of wins to losses is going to be 21 to 10. Can I simplify that ratio? No, I cannot, so there we go. For part B, what fraction did they draw? Well, looking at this, if they won 21 out of 35, now we don't know how many games in a total, that's just the fraction in its simplest form. Well, not in its simplest form, but in terms of this, they lost 10 out of 35. So here what I just need to do, so the draw is going to be the difference from 35 of these two. Now if I add these two numbers up I get 31, so that means out of 35 there's going to be 4 games left, so it's going to be 4 out of 35. So the fraction there is going to be 4/35. And again, can I simplify that fraction? No I can't, so that there is my final answer. Part C then says what is the ratio of wins to draws to losses. Now again I'm going to use these 3 fractions that I've got here, and again the reason why I'm going to use those 3 is because I've got a common denominator of 35. So here I've got wins to draws to losses, so here I've got 21, I've got 4, and I've got 10. And again, can I simplify that ratio? No I can't, so that there is my final answer. Now part D, it says, is it possible for there to have been a total of 35 games in a season? Well, yes there can. And the reason for that is because if I look at the fractions, now the fractions here I've got draw is 4/35, is because I can actually work out, and the denominator can be 35 for each of these values. So the answer to this is going to be yes. And the reason for that is because I can actually work out what 3/5. Can I work out what 3/5 of 35 is? Well, yes, it's going to be 21. Now, if you're not sure how I'm doing this, there is a video on how to work out fractions of quantities. Can I work out what 2/7 of 35 is? Well, if I do 35 divided by 7, which is 5, times 2, which is 10. And can I work out 4 35s of 35? Well, yeah, of course I can, because I can do 35 divided by 35, which is 1, times 4, which is 4. Now, because all of these three numbers are whole numbers, it means that 35 is a legitimate number for the games in the season. So in other words, that's going to be the minimum number of games I could have. So I could have in a season any multiple of 35 games in a season. So I can have 35, I could have 70, I could have 105, I could have 140, I could have 175, and so on games in the season. Obviously 175 is going to be a little bit more chaotic. It's pretty much a game every 3 days. Anyway, so hopefully this kind of makes sense and hopefully highlights the links between fractions and ratios, but also you're more comfortable and sort of been introduced on how the two types of things in maths can be interlinked in a particular maths question that you could easily get in an exam.